Hey there. So this should be the last video that covers everything that's going to be in the project. So for where we started off last time is we had the pressure loads acting on our model that should have been completely free of free edges. And now what we're going to be doing is actually doing a nodal force and then doing a static analysis on that. So before we start anything, make sure you have good bookkeeping and you start renaming things. For example, this one was modal analysis. I changed it to second modal analysis and I specified that it was the one that we saw once it was fixed. If you have other ones, just rename them as well. I renamed the static pressure. Um, I open it up and I made this one the pressure case. And once we do other things, it'll be good to have written specified names for everything so that we can easily see what was what once we look at the results and the analysis. Okay, so what we're going to do is we're going to go to model, load, and we're going to create and manage set. Here, we want to create a new load set, right? And we're going to name this, okay. And now we're going to see that the arrows actually go away. And that's because in this load set, the pressure loads don't exist. We can specify new ones. So let's go specify some loads here at the nodes that intersect the front rear spar and the tip rib. So those nodes right there. So you press OK, and let's do this nodal load positive Z global, and let's do 500 pounds each in the Z direction. I place these nodal loads in the rib geometry layer. No worries, we can just modify that by going to modify layer and then load. So let's say I want to move all of my load sets and let's move it to the spar. Okay. Right, so that's the only thing we have to do for nodal loads, and we can go and start our analysis. So we would have an analysis set that actually is for these nodes. I have one created here already, but you would just create a new one and press OK. Now, one thing you want to check before you actually run the analysis is that in your boundary conditions, you do have this nodal load set selected, because you can have other sets selected, kind of how you had the pressure ones in the previous analysis set. But obviously, for the nodal loads analysis, we want the nodal loads. So let's press Analyze. The analysis set is done. So I have this deformation and stress formation, which is similar to the pressure case, but slightly different. And we might ask yourself, well, why? Obviously, because we didn't do the math to get the actual um, nodal loads that would equate to our pressure loads. And we can actually check that if we go to Tools, Check, and we sum all of our forces around the origin for our moments. We press OK, and we do all load sets. So let's do OK. And if we open up the messages window, we can see our pressure load set here at the top and our nodal load set here at the bottom. So for our pressure load set, we have a Z force of 819, which is similar to our 1000, but not spot on. But we also have these small Fy and Fx forces that aren't accounted for in our nodal loads. And in our pressure forces, these arise from the fact that our surfaces aren't completely flat here at the bottom. So when we put normal loads, normal pressure loads with respect to the elements or the surfaces or whatever, they will not be perfectly in the Z direction. And this, of course, creates differences in moments, which causes differences in your stress formation. So even though we have different displacements, as you can tell in the bottom left corner between both cases, we do get similar results. And just like how we do in the pressure case, if we look at the spars, we can actually see the stress distribution along these spars that has very little effect because of the holes. The holes don't affect that as much as one might initially think, which is, you know, as said before, expected and good for weight saving. So this next portion is going to overview how to put the stringers in your model. And what you want to do is you want to undeform it and take off the contour and turn on your geometry. So for this one, we are going to do a mesh of our curves, and we are just going to select all of our curves. Now, something to note is for some of these curves, it will not actually select everything in its entirety. So we have little gaps that we have to connect with these curves. So that's just something you should look out for. Quick visual check. It seems everything is properly selected. So, okay, and I'm going to mesh this with my stringers, flanges, and truss. So we press OK. So we see a few nodes were merged, a few elements were created. We still have to take care of this truss structure that's inside bay 1. So if we notice, the geometry doesn't line up with our nodes. We have the geometry ending on one point here, but our node all the way over here. So I prepared you guys for this by having a couple of points actually between both of them. So if we go to modify and we go to move by node, we can actually select the node that we want to move it along a vector, and we can choose the points. We can choose the points as a methodology of moving it, where our base point will be where our node is located, and our tip point will be where we want to move it. So if we create our vector right there, we can actually see a preview of how it's going to be moving. So we press OK, and now it lines up. That node moved from this yellow cross to where it currently is. And we want to do that for these other 3 locations that we have right here. Now this is meant to showcase just how much movement there is in FEMAP, the availability of different tools for you to modify things. So if you mess up on one thing, there is the option of modifying it. That last one right there. So now we should be able to create our element. Make sure we have the rod line element selected, and we can select the nodes that we're going to be connecting as a singular rod. Select all the ones that we just moved. Right, so if everything went smoothly, we should be able to turn off our geometry and see all of the elements. Here we have the truss, and if we turn it in, we can see those flanges and elements right there. So something you might note is some of these elements look solid, but if you actually go to list elements, you can see that they're individual elements. So even though the nodes aren't exactly lining up there, um, or aren't exactly showing, it's likely because they're existing in a different layer, like the skin. So now one final thing that we have all of these elements created for our internal structure is actually want to this as a thick structure. So if we go to element orientation shape, we can turn on the cross section for all of our elements, and our stringers will show a lot easier than they were just showing. And our ribs and spars will have a certain thickness as well as our skin, although it thickness for the ribs and the spars because they're not transparent like the skin is. So let's press OK. And there might be some problematic areas with this stringer, the top and bottom stringer. We placed some elements where there were already nodes. So even though we um, saw that some of the nodes were existing there, they might be overlaid, which is something that we need to take care of. So let's do that by first doing a coincident nodes check. Get 36 nodes checked, and now we want to do a more aggressive coincident node check right here in this area. So if we angle it just like this, we can go to Tools, check Coincident Nodes, and we will actually pick the nodes by drawing a polygon around this section. It's got all of these selected right there. We press OK, and let's do an aggressive check of 1/2 inch. So there were two nodes merged right there, two nodes that did not visually seem like they were disconnected. And we're going to do the same thing for this one here, bottom stringer. Pick the polygon, all those nodes that it's selected, press OK, and 1/2 inch, 5 nodes merged. Now, let's visually look at the model one last time before running it to make sure that there's not going to be any fatal errors that arise. So now we are ready to analyze, and we can just come here and press Analyze Model, which will take the last analysis that we used and analyze the model. And we have no fatal errors, so that's perfect. That's good. And just to keep some sort of bookkeeping structure, we want to rename this one to stringers. Latest one to be with stringers. And let's say this is no string. Again, the names are up to you, but something that you can read and really follow through if you need to go back and see what each analysis really tells you. So let's look at the deformation of these model. So we see the stress distribution and it makes sense, but the deformation doesn't. We have 19 inches as opposed to 2 inches, which, when we're adding these stiff structures, they shouldn't be increasing our deformation by almost 10 times. And what we see if we look at the inner side is actually this displacement of, uh, of this node, this rod, it's expanding more than what is realistic. So we just do a check of coincident nodes for this node and the node that it's supposed to be touching over here. And then we up the tolerance to something very high and we solve it. So when it's merged, it won't change because the analysis has already been done, but we can do another analysis. So let's just press that same gear again to run the same analysis we just ran and see if it changes. Activate it. And sure enough, we fixed our issue right there. And our deformation is something more realistic, 2 inches. So let's just delete this set. And we can now rename this one to our with stringers case. This one will just be stringers. Now when we look at our deformation and our stress buildup in our structure, we can see that by 0.2 inches, there's difference because of the rods. You can see how the rods are attached in one and on the other based on this deformation. So the stress buildup starts to concentrate around these rods, but it does make the structure just a little bit stiffer. That concludes this portion of the project where you set up the model and you analyze it to verify the inclusion of stringers and how they affect your structural model. Note that you can change the dimensions of everything used in this model by just going to modify, edit your property. And if you changed one of them, it will affect the rest of the model, and you'll have to run an analysis to see the change in that. So you can play around with that and see the change in stress formation as well as deformation with the area of your stringers or the thickness of the plates that correspond to your ribs, your spars, or your skin.